In this video, we are going to discuss compound interest. And with compound interest, the definition is on the top of the screen. That is when interest is computed on the original principal as well as on any accumulated interest. You could have compound interest in a debt situation, money you owe, or you could have compound interest where it works in our favor is with investments or like retirement plans. Just to give you an example, to expound more on this interest on interest as well as the principal, think of a credit card situation where typically most credit cards you're charged interest on a monthly basis. So if you use your credit card but you do not immediately pay off the entire balance, what happens is the remaining balance is carried over to the next month and you make more charges. So what happens is that interest is charged to you for borrowing the money in the first place. So not only do you have to pay back what you originally borrowed with the initial transactions when you charged those items, when you're purchasing them, but now you have to also pay interest on top of that. So that's how compound interest works. And again, with debt, it's not so much fun, especially with high priced items like a car or a mortgage on a home. But where it really is in our favor and where we see a greater return of money is with an investment situation, such as I mentioned earlier, retirement plans and other types of annuities. So unlike simple interest, compound interest is calculated at regular intervals. So in other words, your interest amount that you're going to be charged is recalculated. That is what the word compounded means. So each time that interest is calculated, it is said to be compounded. So again, just think whenever you see the word compounded in these word problems, that's how many times your interest is going to be recalculated. And you might want to take a screenshot, a picture, or write down in your notes what is below where it says interest might be compounded, because this tells you what to plug into little n in the compound interest formula. So what I'm highlighting here in red, this is super important to jot this down. So if your word problem says that the interest is compounded annually, that means your interest is once a year, so you would plug a 1 into all your little n's in the formula. If it's compounded semi-annually, then you will plug in 2 into all of the little n's. If it's quarterly, that's 4 times a year that your interest is recalculated, so all the n's equal 4. If it's monthly, then 12, because of course 12 months in a year, so all your n's will be 12s. Daily, your n will be 365, since 365 days in most years with the exception of leap years. Weekly, your little n will be 52, because 52 weeks in a year. And then bi-weekly, n is 26, since 52 weeks in a year, so half that, so every other week would be 26. So all this is related to the unit of years. So how many times a year, in other words, is your interest going to be recalculated? That is all that this little n represents. The compound interest formula that we are going to use a bunch in this section says after t years, the balance, so in other words, the full amount A, which is in your account with principal P, and the annual interest rate R, which needs to be converted to a decimal before it goes into the formula, which was the same in the last video about simple interest, so nothing's changed there, is given by the following. So for n compounding periods per year, here's the formula we're going to use a bunch. So the full amount that's in the account, or the full amount you owe if it's a debt situation, is going to be, you're going to take the principal, the original investment or the original amount borrowed, P, times parentheses 1 plus interest rate R divided by n, close your parentheses, raise it to the n times t power. So n times t is an exponent. You'll want to make sure you locate the exponent button in whatever calculator you're using. I'm going to strongly encourage you to download a free graphing calculator app onto your phone or use free graphing calculator websites. The buttons are all in the same spots as an actual graphing calculator. And what's nice is you could just type in this big old formula right onto the main screen so you can make sure that everything looks okay before you push enter to get the answer. But again, please keep in mind that nt is your exponent, n times t. And then also note that n is listed twice in this formula. So that's why I made such a big fuss about you need to know what to plug into n, because you're going to plug into n here, and there's also the exponent up here. Okay, so let's go ahead and see this formula in action. So looking at example 1, you deposit $2,000 in an account at Hometown Bank, which has a rate of 1.6%. We got two parts, an A and a B. So part A, find the amount A of money in the account after 3 years, subject to interest compounded once a year. Round your answer to the nearest cent. So we will go 2 digits past the decimal point when this is all said and done. So when you see words like compounded, that's going to be your cue to use our new formula. So let me go ahead and copy and paste our new formula down here. So A equals P times the quantity, so parentheses 1 plus little r divided by n, close the parentheses, raised to the n times t power. I'll make my t curvy so it doesn't look like my plus symbol. And let me just jot off to the side what we're plugging in where. Keep in mind we are solving for A, and what's nice about that is that the formula is already set up and ready to go to give us that full amount, the full balance in the account A anyway. So we just need to know what to plug into the right side of the equation, all those variables. So starting with principal P, again, I'm just going to write this off to the side. That's the original amount invested or borrowed. So in this case, it's an investment situation, and you deposited $2,000. So P is going to be 2,000. Then we need R, little r. That's usually easy to identify because it's the percent, it's the interest rate you're going to be given. So here it's 1.6%, but remember the catch is the same as the last video, the last topic we discussed. You need to get rid of the percent symbol by converting that to a pure decimal before it ever goes into any formula. So as we mentioned in the last video, that means you need to simply move your decimal point 2 hops to the left. So here's hop 1, here's hop 2, plunk down your decimal point. We need an extra 0 there as a filler spot. Then we can get rid of the percent symbol. So R is 0.016 converted to a pure decimal. That's the interest rate as a decimal. You do not need to put another 0 in the whole number spot. I've found that when students do that, they sometimes make a mistake when they type it into the calculator. So I'm just going to leave that as 0.016. Next up are those two little n's. This one's a little bit trickier because usually it's a word around compounded. So in this case, it says compounded once a year. Normally, it would just say annually. Compounded annually means the same thing. But either way, once a year or annually, if you look up here near the top of the screen, that means all the n's are equal to 1. So n is 1. Let me erase some of these extra colors going on because they're a little distracting. There we go. Okay, and then we just still need the time. It's part of the exponent there of the formula in years. So the time is 3 years. So the money is going to accumulate in the account for 3 years, so T is 3. So let's go ahead and plug in. So our full balance, full amount in the account A equals, so P, swap it out with 2,000 times 1 plus r is 0.016 over n is 1. Close the parentheses. Another n and the exponent is 1 again. Times your time t is 3. I'm going to go ahead and erase to give us a little bit more room. But now we know what to plug into the formula. I like to encourage people to do the exponent first before you put it into the calculator. But if you wanted to, you could put that whole mess as is into the calculator. That's fine too. But if I do the exponent only, 1 times 3 is obviously 3. So now I'm going to type in 2,000 parenthesis 1 plus 0.016 divided by 1. Close the parenthesis and raise it to the third power. And we'll go ahead and round whatever decimal comes out, and let's see what we get. This is the graphing calculator I've downloaded on my iPhone. There are a bunch of different versions for both iPhone and Android phones. But just typing in that right side exactly how we have it written, we had the 2,000 first, so 2,000. Your left and right parentheses are going to be located above the 8 and the 9 buttons. And by the way, I apologize if the timing is off. Whenever I go over to the calculator, I've noticed, and I import it into my Explain Everything app, the timing for some reason is a little out of sync. But you're looking above the 8 and the 9 buttons are where your parentheses are going to be. So then I'm going to hit the left parenthesis. Again, what's nice about the graphing calculator is I'm going to make it look exactly like what I have written on my paper. And then 1 plus point, decimal points on the bottom middle, 0.016 divided by 1, close the parentheses. Your exponent button is above the division button. The up arrow, they call that the caret. And what's nice is that when you hit that, your cursor will float in the air like an exponent. And then we already did the 1 times 3 for 3, so 3 is our exponent. Oops, let me press a little harder. There we go. So 3, and then I hit enter on the bottom right for equals. Here's our answer. They want us to round to the nearest cent, which means 2 digits out. Using normal rounding rules, I just simply look at the digit after, directly after where I want to round to. It's a 4, so that means I'm going to round down. In other words, I'm going to leave it alone as 54 cents. So my final answer is $2,097.54. I'm going to go ahead and jot down that answer. So again, it was $2,097.54 would be the full balance, the full amount in the account. Okay, so now part B, find the interest, round your answer to the nearest cent. So that's just the interest alone that accumulated in the account. There is not a special formula listed for interest. However, if we think it out logically, we're working backwards. So we know the full amount that's in the account. So all we need to do to get the interest is simply subtract, so the full amount, the full balance, minus what you originally deposited. So that's the principal. So to get interest I, just think it's A minus P. A minus P. You might want to jot that formula down somewhere on your handout. So when I do that, the interest I, the full amount, well, that was your answer to part A. That was the $2,097.54. $2,097.54. You're going to subtract the principal P, which is what you originally deposited, which was $2,000. I'm running out of room, of course. But when you do that, $2,097.54 minus the $2,000, I'm going to write it over here. I can fit it way over here on the left side. I apologize, I'm running out of room because I have all these buttons on the bottom of my screen. It won't let me write any lower. You know what I'll do? Actually, let me just erase. That's what I'll do. So when you do that, let me just erase this top line. I got big handwriting issues here. There we go, to create some space. So when you do that 2,097.54 minus the 2,000, you're left with a final answer of the interest is $97.54 for interest part B. Looking at example 2, you deposit $7,500 in an account that has a rate of 1.2%. The interest is compounded monthly. Part A, how much money will you have after 5 years? Round your answer to the nearest cent. And then B will ask for interest again, but let's start with A. So they're talking about interest being compounded. As long as it does not say compounded continuously, you can use the compound interest formula, which we said from the last slide. The full amount, A, equals principal P times the quantity, so parentheses 1 plus R over N, close the parentheses, raise it to the N times T power. So yet again, they want the full amount because this is how much money will you have after so many years. So they want the full amount A. So let's off to the side yet again. Think about what we're going to plug into all the variables on the right side of that formula. So principal P, the original amount borrowed or deposited, well here we deposited $7,500. So P is going to be $7,500. Next up is R. That's the percentage interest rate, 1.2%. But when we convert it to a pure decimal, slide that decimal point 2 hops to the left. So here's hop number 1, hop number 2. And to get rid of the percent symbol, it now is 0.012. So little r is 0.012. And then the n, which there are 2 little n's in this formula, look around the word compounded. It's usually a word. So compounded monthly, if you look up from that first slide, what I was mentioning to write down or screenshot somewhere so that you save that information, compounded monthly, then all your little n's will equal 12. Because that means your interest is going to be recalculated 12 times that year. So 12, whenever it says monthly, and then that curvy T for time in years, well, it's going to be 5 years, so T is 5. So let's go ahead and plug all of this in. So the full amount A equals P is 7,500 times 1 plus R is 0.01 over N is 12. Close it. Another N, so another 12 in the exponent times T in the exponent, which was the 5. And I can get rid of what I don't need anymore. So we plugged into all the variables. Again, I recommend taking care of the exponent first. So when you do that 12 times 5 for the exponent, you get 60. So go ahead and in your calculator, whatever calculator you're choosing to use, type in the right side of that equation. So 7,500 parenthesis 1 plus 0.01 divide by 12, close it, exponent button 60. And you're going to round to the nearest cent, which is 2 digits out. If you want to pause this video and see what you get, you should be getting, after you have tried it on the calculator, $7,963.54. If you're not getting that, feel free to reach out to me and we can see what's going on in your calculator. It does really help if you have a graphing calculator, and the apps are free and there's free graphing calculator websites, but that calculator is going to be a lot easier to use than trying to use, the default calculator on your phone. $7,963.54. Part B, find the interest after 5 years. Round your answer to the nearest cent. We said with the previous example that the interest I alone equals the full amount A minus P. So A was your answer to part A, which was the $7,963.54. You're going to subtract principal P, the original amount deposited or borrowed. In this case, it was deposited. We already said earlier P is $7,500. So you're going to do 7963.54 minus 7,500, and your interest final answer should be $463.54. $463.54. Okay, let's try another one with how the homework likes to phrase these types of questions. So if I look at example 3, it says the principal represents an amount of money deposited in a savings account subject to compound interest at the given rate. So the principal, they say in this chart, is $9,500. The interest rate is 0.7%, compounded quarterly. The time frame is 5 years. There's an A and a B. So part A, find how much money there will be in the account after the given number of years. Assume 365 days in a year. So we don't have to worry about like if there's a leap year or that kind of scenario here. Okay. So they're talking about compound interest. It's not compounded continuously. We'll learn about that concept later in this video. So when you see the word compounded, but it's not compounded continuously, and they want the full amount of money, those are all cues to yet again use the compound interest formula, which was A equals P, left parenthesis, 1 plus R over N, close the parenthesis, raise it to the N times T power. Let me go ahead and write off to the side what we're going to plug into all of the variables on the right side of the formula. Because it says find out how much money there will be in the account. So in other words, we are solving for full balance, full amount A. So principal P, well, they tell you in the chart right here, that's $9,500. And then R, be careful here because yet again, it's a percentage. So you're going to have to convert that to a pure decimal, which is 2 hops to the left. So here's hop number 1, hop number 2. You end up with 0.007. After you slide that decimal point 2 hops to the left. The 2 little n's in the formula, look around the word compounded. It's quarterly. So if you go back to the first slide in this handout, we said quarterly means 4 times a year that interest is recalculated. So all your n's are 4. And then finally, time t is 5 years. So what's nice with this question is they just give you all of the information right in the chart. So just simply plug everything in. So your full amount A equals P was 9,500. Left parenthesis 1 plus R is 0.007. Over N is 4. Close the parentheses. N on the exponent is 4 again. Times the time is 5. Let me erase some of this to create some room. Just like with the other examples, I recommend doing the exponent first. So the 4 times 5 is obviously 20 is your exponent here. Go ahead if you want to even pause the video. Try plugging that right side into the calculator. Don't forget that the 20 is an exponent, so you do need to, of course, hit the exponent button before you type in the 20. And if you've typed it correctly, when you round to the nearest cent, you should be getting $9,838.09. $9,838.09. Part B, just like with the first two examples, wants the interest earned. So we said interest I is going to be A minus P. A minus P. So that's going to be that $9,838.09, our answer to part A, minus principal was the $9,500. Go ahead and subtract $9,838.09 minus the $9,500. Your final answer for interest is $338.09. $338.09. Final answer for part B. We've discussed the compound interest formula, which is listed again under number 1 in the yellow rectangle. We also discussed, since that formula actually generates the full amount after the compound interest is implemented, how to work backwards by simply subtracting to get the interest. So now let's go ahead and discuss compounding continuously or continuous compounding. Same thing. So continuous compounding is where the compounding periods increase infinitely. So you're compounding interest every trillionth of a second, then every quadrillionth of a second. So it's just constant compounding, in other words, recalculating of the interest. Now this unique formula is going to involve the number e. And it's going to look like a little e, so lowercase e. And this little e is called Euler's number. Euler's number, named after the mathematician that had published a bunch of research regarding this number. And it is pronounced Euler, his last name. I know it looks like it should be Euler, it's not. So it's technically pronounced Euler, I'll put in quotes. But this e is an irrational number. So it's a decimal that does not repeat the same pattern and that goes on forever. It kind of reminds you a little bit of like the number pi, and that pi is also an irrational number. If you were to round e, it's approximately 2.71828. However, when you punch this into your calculator, it's preferred if you just simply use the E button. So on any calculator, there is going to be an E button you can use. Even on the default calculators that come on your phones, if you tilt your phone to the side and you allow auto rotate, there will be more buttons, more features that appear, including this E button. So whenever it literally says in the word problem, continuous compounding or compounding continuously, as soon as you see that word continuous, you're going to use what I call the PERT formula. So now the full amount, the full balance in the account is the principal P times the number E raised to the R times T power, where all the variables still represent the same exact items as they did in the regular compound interest formula. But please notice in this formula that only the number E is raised to the R times T power. Only the number E. So not the principal, just the number E. Super important, again, before you begin these examples, that you locate where your E button is. On the graphing calculator, there are two different E buttons you could use. Graphing calculator, two different E buttons we said you could use. The first one is right here. Now your colors might be different colors than mine depending on which version graphing calculator app you're using. Mine happens to be yellow, which means I need to hit 2 button clicks. So my first E option is it's right above the division button. It's on top of actually the division button. So I'm going to think color coding. So I hit second, and after I hit second, I hit the division button, and E comes onto the main screen. So that's option 1. And by the way, if I hit enter, you can see what I mean by it's a very long decimal irrational number. It's about 2.72 if you're going to round that. The other E button will come with the exponent right after it, and that's going to be above the ln button. So locate the number 4 on your calculator, your graphing calculator, and look to the left of that. You'll see ln for natural log. Right up there is e raised to the x power. So again, I got to color code it. So I'm going to hit second, followed by ln. And what's nice about this e feature is not only do you get e, but the cursor is already floating in the air in the exponent ready to go. So let's go ahead and see some examples of this formula. In a lot of the word problems, they will have you use both the compound interest formula and this new continuous compounding formula. So you can compare the money amounts, the returns, to see which investment would give you a greater return, meaning more money back. So let's go ahead and see example 4. It says you decide to invest $8,000 for 6 years, and you have a choice between 2 accounts. The first pays 2.5% per year, compounded monthly. The second pays 2.49% per year, compounded continuously. Which is the better investment? So which is going to give you more money? So this is actually 2 parts to this question. So we're going to compute using each formula. You're going to invest the same amount for both formulas, by the way. So the P, the principal P, the original investment amount in both formulas is going to be $8,000. And let me go ahead and draw like a little divider down the middle here. So on the left side, let's do that first sentence, which is compounded monthly. The first pays 2.5% per year, compounded monthly. So this is, oh, sorry, it's a little messy. Let's try this again. This is the monthly compounding. I'll just put COMP to abbreviate. So it is for any compounding that's not continuous, we use that traditional formula from the previous slides, which is A equals P times the quantity 1 plus R over N, close the parentheses, raised to the N times T for time power. Let's think about what to plug into the right side. We are looking for the full amount, the full balance A in the account, equals the P we just said we're going to replace with 8,000, parentheses 1 plus the interest rate. Be careful here, you get 2 different percentages, 2 different interest rates in this word problem. So right now we are only focused on the compounded monthly account. So that one was linked to the 2.5%. You do have to convert it to a pure decimal before it goes into the formula. 2 hops to the left makes it 0.025. 0.025. And as usual, I would recommend not putting the 0 in the whole number spot because you're more likely to put something incorrectly into the calculator if you type it in that way. So I'm just going to leave it as 0.025 for R. All over the N on the bottom, well, compounded monthly, all of your N's are 12. 12. When that happens, going back to the first slide in this video, close the parentheses, another N is the exponent for 12 again, times T, time in years. So for both of these, it says 6 years. When I go back to the very first sentence, let me erase a little bit so we can see this better. But right here, it says 8,000 for 6 years. So actually, let me do this. I'm just going to write off to the side. Again, for both of these, P is 8,000, and the time frame for both options, both account options, is 6 years. So T is 6. When we plug that in, we go back down to our formula here. All right, as usual, I would recommend doing the exponent first, although you don't have to. So I'm going to do the 12 times the 6, which is 72 as my exponent. So go ahead and type in 8,000 left parenthesis 1 plus 0.025 divided by 12, close the parenthesis, exponent button, don't forget the exponent button, 72, into your calculator and see what you get. If you want to pause the video and then see if you get the same answer as me right now. And they should tell you how far to round it. Usually it's the nearest cent, so I'm going to go ahead and round it to the nearest cent. So when you use normal rounding rules, you should be getting $9,293.22 if you've typed it correctly. If you did not get that, let me know and we can see what's going on with your calculator. If you're doing this online, you want to send me a screenshot or a picture of your calculator, that works. If you're coming in person classes, show me what you have on your calculator screen and we can see what's going on in that calculator, but you should be getting $9,293.22 if you go with the compounded monthly option. So now let's go ahead to the second account option. So the second account says the second pays 2.49% per year compounded continuously. So as soon as it says compounded continuously, it's time to use the new formula, the PERT formula. Let me jot that down. So this is the compounded continuous formula, full amount A equals principal P times the number E raised to the R times T power. So plugging in to find A, P we already said for both accounts is 8,000. Plug it in. Bring down the number E, and E is raised to the R. So here was your interest rate for compounded continuously. However, it needs to be converted to a pure decimal before it goes into the formula. So as usual, let's slide that decimal point 2 hops to the left. Here's hop 1, hop 2, and we get 0.0249. And now times the time t is also an exponent. Time frame for both accounts is 6, so times 6. And there we go. Now all we have to do left is punch this into the calculator. Just like with the other formula, I would recommend do the exponent first. It's usually some weird decimal, just as a heads up, in the PERT formula. But let's go ahead and type in 0.0249 times 6. And when you plug just this exponent in right here, 0.0249 times 6, you should be getting as the new exponent 0.1494. So I just did the exponent first to be consistent with the other formula. So that was decimal point on the bottom row of the graphing calculator, 0.249 times 6, enter on the bottom right corner for equals. That's where I'm getting that 0.1494. And yet again, don't worry about putting the 0 in the whole number spot. You can leave it just like that. I did make my decimal point really large just to remind myself to punch in the decimal point when I put the whole formula in here in a second. So that is where I got that 0.1494 from. That's the new exponent. Now I'm ready to go ahead and punch the entire right side of the formula into my calculator and get the answer. First, I type in the 8,000. I'm going to type it in exactly like it looks like on my paper, 8,000. You don't even have to put the times button. Honestly, you can go right to typing in the E. Just mush it up next to the 8,000, and the graphing calculator knows that that means multiplication. It's up to you which E you want to use. I'm going to use the E above the division button. You do need to color code it. Mine's yellow. It's 2 button clicks to get that E up there. So second button, followed by the division button. So second, followed by the division button. You're going to know if you've done it correctly because E will come right onto the main screen. If you mess up, that's okay. You can always clear it out. The clear button is below the down arrow. Clear it out and just start over. And then now we need the exponent button. Don't forget the exponent, which is right here above the division key. And type in that weird decimal exponent, which is 0.1494. 0.1494. Check it, make sure it looks exactly like you have it written on your paper. Hit the enter button for equals. Let's go ahead and round it to the nearest cent. You should be getting $9,289. And because of the 8, that's the third digit, I need to round the 9 cents up to 10 cents. So $9,289.10. So jotting that down, the full amount with the continuous compounding scenario is approximately, we did round it, so I did the little approximately wave there, $9,289.10. So now we've computed the monthly compounded account, the continuous compounding account as well. We're ready to go back to the question, which is the better investment? So just simply compare the two numbers, see which is bigger. So we have 9,293 and 22 cents or 9,289 and 10 cents. So it's a little bit bigger, only a little over $4 bigger, but hey, still larger is if you go with the monthly compounding scenario. So which is the better investment? You would select that the better investment is the 2.5% compounded monthly account. The 2.5% compounded monthly, that's what you would select, is the better investment for the final answer. Usually with these types of questions, you would either just select like multiple choice, which is the better option, although they might ask you how much more of a return would you get with the better option. If they do go on and ask you that, you would just simply subtract the larger amount minus the smaller amount. So like in this case, you get $4.12 more of a return when you just simply subtract those two numbers. Let's try one more of these though, just to make sure we have them down pat. So now I'm looking at example 5. It says, suppose that you have $12,000 to invest. Which investment yields the greater return over 3 years? So 4.15% compounded monthly or 4.1% compounded continuously. Very similar to the last example. In fact, if you wanted to give yourself some more practice, you could pause the video right here and see what you get, and then we can see if our numbers match. I'm going to go ahead and draw that little divider again. So first up is the 4.15% compounded monthly. So that is going to be the regular compound interest formula, which was A equals P times 1 plus R over N raised to the N times T power. The P, principal, the original investment in both accounts, is going to be $12,000. So let's go ahead and swap out P with 12,000. Left parenthesis 1 plus R converted to a pure decimal. So the interest rate is 4.15%. When you move that decimal point 2 hops to the left, you get 0.0415. All over, let me move my divider over because already I'm running out of room here with my big old handwriting. Move it like right there. There we go. All over N, so compounded monthly means N is 12. All over, we have another N in the exponent, so 12 again, times the time frame in years for both investments is 3 years, so T is 3. And I know I'm going kind of fast because we have done a bunch of examples of plugging into R and T. But if at any point you want, you can always, pause the video and go back over what I just wrote. But that's how it looks after the initial plug-in. Okay, let's do the exponent first. So the 12 times the 3 is obviously 36. And now you're ready to punch that right side into your calculator. When you punch it into the calculator and you round to the nearest cent, if you're doing it correctly, you should be getting $13,588.07 with the compounded monthly scenario. Let's go ahead and take a look at the other scenario, which is 4.1% compounded continuously. So whenever it says continuous or continuously, that's your cue to use the PERT formula. A equals principal P times E raised to the R times T power. So A equals, we already said the principal P, the original amount, that's always what principal means, is 12,000 times E raised to the R. So the interest rate here is 4.1%. When you slide that decimal point 2 hops to the left, it, as a pure decimal, is going to be 0.041. 0.041 times the time frame for both accounts is still 3 years. So now it's set up and ready to go. Let's do the decimal first. It's going to be a funky decimal. So let's do the exponent first, which is going to be a weird decimal because you have 0.041 times 3. So that should give you 0.123. 0.123 as the official exponent. Go ahead and try typing that into your graphing calculator or your graphing calculator app. If you're doing it correctly, you should be getting $13,570.61. $13,570.61. I promise it's supposed to be a 6. Let me try writing it a little nicer. So 61 cents when you round to the nearest cent. So as you compare these two amounts, yet again, the compounded monthly is slightly bigger. That's not always the case, I promise. This amount is slightly bigger. So the better return, the better investment is if you go with the 4.15% compounded monthly that I'm circling right now. That's what you would select. I'll do a little arrow even to it as your final answer. The investment that yields the greater return, more money for you, is if you select the 4.15% compounded monthly account. The next formula up really is not a new formula. It's actually just the compound interest formula, just solve for P. So if you want P, you would use this version of the formula that has already been algebraically solved for P. Principal P is also known as the present value. So this is going to give you that present value amount. So you might be going, okay, well, I'm going to see the word compounded again. How do I know to implement this version of the compound interest formula versus just like the regular compound interest formula? Well, you're going to know because A, you'll already have a financial goal in mind that you want to obtain. Like they're going to say, you want $10,000 at the end of this, or you want $20,000. But then in addition to that, B, you're going to get a phrase such as, how much should you deposit today? Or how much should you invest now? How much money should you be putting forth now into the account? So when you see a phrase like that, which I've underlined in red, that's going to be your cue to use this present value version of the compound interest formula, which says that P equals the full amount A divided by the quantity, so left parenthesis, 1 plus r over n, close it with a right parenthesis, raise that denominator to the n times t power. There's a little dot on the end, that's just the period, the punctuation there in the box. You can ignore the little dot you're seeing. But you are solving for p. Now, because you are planning for the future, you already have a set financial goal, A, in mind. This is not normal rounding rules. You will always, always, always round up whenever you use the present value formula. And it's going to even say that somewhere in the word problem. So be on the lookout for that. It's going to say round up, whether it be to the nearest cent or nearest dollar. Just automatically round up. Not normal rounding rules ever for the present value formula, which is you're solving for P. Let's go ahead and see this formula in action. Looking at example 6, how much money should be deposited today? So already I'm circling that phrase. That phrase is my cue that I am solving for P, present value or principal P. In an account, so how much money should be deposited today? In an account that earns 7% compounded weekly, so that it will accumulate to $10,000 in 8 years. Round up to the nearest cent. So already it's a different feel, a different vibe from those compound interest formula questions we were doing earlier in this video. We saw that key phrase, how much money to deposit today or now, and we already know how much total balance we want in the account eventually, which is $8,000. So these are all clues, if this were my homework question, to use the present value formula. So let me copy and paste it down. That's P equals the full amount A divided by parenthesis 1 plus R over N, close the parenthesis, raised to the N times T power. So thinking about what to plug into the right side of the formula, since we're solving for P, I'll write it off to the side. The full amount, the full balance we want in the account when this is all said and done, says will accumulate to 10,000. So A is going to be 10,000. R, the interest rate, is the percentage, 7% converted to a decimal. We can assume the decimal point, since we do not currently see it, is just hanging out there at the end after the 7. So slide that decimal point as usual 2 hops to the left. Hop 1, hop 2, we need to insert a 0 because we run out of room. And we get 0.07 is the same as 7%. We do need to, again, insert a 0 as a filler spot after the second hop. But 0.07 is your interest rate converted to a pure decimal. And the time frame is 8 years. So let's go ahead. Oh, and the N. I almost forgot about the N. Look around the word compounded. Weekly. So how many weeks in a year? Well, if you forget, go back to that first slide of the video. We said weekly is going to be 52. So all the N's should be 52. Now we're ready to go. So bring down the P you're solving for equals. A on the right side is 10,000 divided by parenthesis 1 plus R is 0.07 all over N is 52. I already used the 0.07 for R. The N, which we're on now, is 52. Close the parenthesis, raise to another N, so another 52 times time T is 8. So we have it set up and ready to go. As usual, I would encourage you to do the exponent first, even though it's on the bottom of the fraction. So your exponent is 52 times 8. Since I don't have much room, I'm going to erase it and replace it. So 52 times 8 is 416. So let me erase this. So you end up with 416 as your exponent to the quantity in the denominator. Now we're ready to punch that right side, that mess as is, into our graphing calculator. So typing this into the calculator, we have the 10,000 on the top of that fraction, and then the fraction bar just means division, so I'm going to use the normal division button there. Parenthesis buttons are above the 8 and the 9 buttons, so I hit my left parenthesis, 1 plus decimal point on the bottom, middle row, 0.07 divided by 52, close the parentheses. Don't forget the exponent button, the up arrow above the division key. The exponent is 416. Hit the enter button on the bottom right corner for equals. Also, don't forget, we always round up in this formula. It does literally say round up when you read that word problem. So the 24 cents will be bumped up to 25 cents because it says round to the nearest cent. So final answer, $5,714.25. So let me go ahead and jot that down. So P is approximately $5,714.25. So that's how much you should deposit or invest today to get to that final of 10,000 amount. And again, we did round up. We rounded up to the nearest cent. It's not normal rounding rules. Trying one more, I'm looking at example 7. How much money should be deposited today? So already with that phrasing, I know it's another present value formula in an account that earns 3% compounded semi-annually so that it'll accumulate to $12,000 in 4 years. Round up to the nearest cent. Okay, so step 1, let's copy and paste the correct formula on down. Present value formula again, so P equals A divided by parentheses 1 plus R over N, close the parentheses, raised to the N times T power. Thinking about what to plug into the variables on the right side of the formula, the full amount A that you want, well, it says accumulate to $12,000. So A is 12,000. R, 3% converted to a pure decimal, so slide your decimal point 2 hops to the left, and it's 0.03. The two little n's compounded semi-annually, which means twice a year, so your n's are 2. The time frame T is 4 years, so T is 4. So now we know what to plug in. Let's go ahead and plug them on in. So P equals A is 12,000 divided by left parenthesis 1 plus R is 0.03 over N is 2. Close the parentheses. The exponent is another N, so 2 times the T is 4. I know I did that kind of fast, so we want to just verify. I just plugged all these numbers in. 12,000 went into A, 0.03 went into R, 2 went into both of the N's, T 4, so 4 went into T. I'm going to do the exponent first of 2 times 4, which is obviously 8. We're getting there, we're chipping away at it. So 2 times 4 gives me an exponent of 8. So now plug that right side into your graphing calculator. 12,000 divided by left parenthesis 1 plus 0.03 divided by 2, right parenthesis, exponent, raise it to the 8th power. You are rounding up to the nearest cent. Go ahead and try it on your own and verify. You should be getting $10,652.54 as the final answer when you round up. $10,652.54. The last formula is going to be calculating effective annual yield. Effective annual yield. So that effective annual yield, also known as effective rate, is actually a simple interest rate. So you are solving for a simple interest rate. Keep in mind all these rates are percentages. So you will have an extra step at the end of these word problems where you have to convert your answer to a percent. But it is a simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. So our formula is going to be, if I look in that yellow box, the effective annual yield is represented with a y, of course, for yield, and it equals parentheses 1 plus r over n, close the parentheses, raised to just the n power. Since time is always going to be 1 year, we don't need to plug into time t. They've already done that for us in the formula, since t will always be 1. So that's why this particular formula is raised to the n power. And then notice at the end, this is what's a little different about it, minus 1. So there always is a minus 1 after those parentheses. Okay, so, and then it says at the bottom, like I already mentioned, the decimal form that you're going to get for y should then be converted to a percent. So let's go ahead and see one of these examples. Example 8. An account has a nominal rate of 2.5%. The interest is compounded quarterly. Find the account's effective annual yield. Round your answer to the nearest hundredth of a percent. So what's nice is that the question will literally say, find the effective annual yield. So you're going to know when to implement this formula. So first step, let me copy and paste the formula down. So yield y equals parenthesis 1 plus r over n, close the parenthesis, raise to the n power, and then minus 1 is back down on the ground. I do want to emphasize the minus 1 is not part of the exponent. Off to the side, let's go ahead and talk about what we're going to plug into r and into those two little n's. So the interest rate is the compound interest rate. I know there's two different rates going on here. There's the yield rate we're solving for, which is a simple interest rate, but then the question also gives you a compound interest rate to plug into the formula. This one, as usual, needs to be converted backwards to a pure decimal. So 2.5%, before it goes into the formula, we need to move that decimal point 2 hops to the left to get rid of the percent symbol. So here's hop number 1. Hop number 2, we run out of room, so we need a 0 as a placeholder. So we see that the rate is 0.025. Let me go ahead and write that nicer. So converted to a pure decimal, 0.025. And then the two lowercase n's, it's compounded quarterly, where n is 4. N is 4. So quarterly is, of course, 4 times a year. Again, if you forget, you can always check the first slide of this video to see what to plug into little n with all of these formulas. Okay, so now we're ready to plug in. So we're solving for yield y equals parenthesis 1 plus r. We're going to swap out with 0.025. All over n is 4. Close the parentheses, raise to the 4 power, and then the minus 1 is back down on the ground. So let's go ahead and just simply type in this mess on the right side into our graphing calculator, and that is going to give us the decimal that will then need to be converted to a percent for the final answer. We will use the parenthesis buttons above the 8 and the 9 keys. So left parenthesis, then we have that 1 plus, decimal point on the bottom row in the middle, 0.025 divided by 4, close the parentheses, exponent up arrow to the 4th power, but take a look at what I have to do here. So my cursor is still floating in the air in the exponent spot, so I have to hit the right arrow key near the top right part of the keypad. I have to hit the right arrow key, and you'll see your cursor slide back down to the ground, and then type in that -1. -1, hit enter. Now, the question said to round to the nearest hundredth of a percent. So planning ahead, we will eventually convert this decimal to a percent. So for us to be able to go to the hundredths spot as a percent, that's 2 digits out as a percent, we're going to round 4 digits out as a decimal. So if I want to go 4 digits out as a decimal, using normal rounding rules, I look at the digit after where I want to round to. It's a 3. So that means I'm going to leave that as a 2 right before it, round down. So it's about 0.0252. So jotting that down, I did round, so I'm going to change this equal symbol to a little approximately wave. So this is approximately, there we go, 0.0252. Now this last step we don't want to forget is that it needs to be a percent. Yield, effective annual yield, is a simple interest rate, which is a type of percent. So this is going to feel a little bit weird because we're used to moving the decimal point in the opposite direction. But to convert that to a percent, now we're moving the decimal point 2 hops to the right. So here I'll do this one in black pen. Here's hop number 1. Hop number 2 lands you between the first 2 and the 5. So that becomes 2.52% for the final answer. And now you see why I chose to start by rounding 4 digits past the decimal point when it was a decimal, because I was planning ahead, and now my final answer after I slid that decimal point 2 hops to the right is exactly how they wanted it, to the nearest hundredths of a percent. So 2.52% final answer. Let's try one more to make sure we have it down. Example 9, what is the effective annual yield? So same formula of an account paying 3.2% compounded quarterly, round to the nearest hundredth of a percent. Okay, so it says effective annual yield. So step 1, jot down your formula. So yield equals parenthesis 1 plus R over N. Close the parenthesis, raise it to the little n power, and then there's a -1 back down on ground level. Thinking about what to plug into the variables on the right side. So R is the compound interest rate. 3.2%, go ahead and convert that to a pure decimal. So that's where we're used to moving the decimal point 2 hops to the left. So here's hop 1, hop 2, and it becomes 0.032. Let me write that a little nicer. So what we're going to plug into R is 0.032. The 2 little n's, well, it's compounded quarterly again. So yet again, n is 4. 4 times a year. The interest to be recalculated for the compounding there. Okay, so now let's go back to the original formula. Yield equals parenthesis 1 plus R was 0.032 all over N was 4. Close the parentheses. raise it to the n power, so raise it to the 4th power, minus 1 on the ground. I'll let you go ahead and try that on your own with whatever calculator you're using. As usual, you might want to pause the video, try it first. Just make sure you're going to get the same thing that I get. But if you've done it correctly, you should get a decimal which rounds to 0.0324. And now, last step, so 0.0324. Check to make sure you've typed it correctly in the calculator and you get that. That last step, it does need to be converted to a percentage where you're going to slide your decimal point 2 hops to the right, which lands you in between the 3 and the 2. So that's 3.24% for the final answer. So in other words, if you have a simple interest rate of 3.24%, like our answer, that's going to generate the same amount of money in 1 year as the 3.2% compounded quarterly would. But that is our final answer. So we've seen a bunch of formulas in this section, but the good news is we were plugging into a lot of the same variables, a lot of R's, N's, T's, P's, and A's.